I'm Anil Kumar. Now we'll factor a polynomial with degree 4. Well, if you observe, it could be written as a polynomial with degree 2 also. Let me show you how. If I substitute x square as y, then what happens? Then x to the power of 4 will be y square, right? Substituting these values in the equation will give me, instead of x to the power 4, I can write y square minus 13y plus 36. So that is how I can change my equation. Now I can adopt the normal ways of factoring. 36, product of two numbers we are looking for. So we say p times q should be 36 and p plus q should be minus 13. So the numbers are 9 times 4, right? Both should be negative, so that when we add we get minus 13. So we can decompose minus 13y and write it as y square minus 9y minus 4y plus 36. Now we can group the first two terms and the last two terms. Factoring y from the first two terms, we get y minus 9, and from the next two terms we can factor 4. That gives us y minus 9. Now y minus 9 is a common factor. So we'll write this as y minus 9 and then y minus 4. Correct? So that is how we can factor it. But see, we wanted what? We wanted in terms of x. And what is y equals to? Y is actually equals to x squared. So we'll get back to our question, right? And then continue. See, we'll substitute y as x squared. Then what do we get? We get x squared minus 9 times x squared minus 4. Correct? At this stage, we can actually apply difference of squares. X squared minus 9 means x squared minus 3 squared, which I could write as x plus 3 times x minus 3. X squared minus 4 is x plus 2 times x minus 2. So that is the final factored form. It's completely factored. You cannot factor it any further, right? So that is our answer. Now, why I did it like this? Because I wanted to show you that we could adopt the techniques learned and do even higher degrees, right? At times, you can get to this straight away. You could think that the function here is this square minus, think like this, plus 36, and you could do product and sum and get the same result. Do you see that? You could have come directly from here to this stage also. Well, I mean, not exactly, but instead of substituting, you could think x to the power of 4 as x square whole square and then continue without substituting. What I mean to say is, you could do from here to this place without substituting. But substitution into x square equals to y helps, right? So that is a suggestion, right? So the method here is substitute. So at times you can substitute, simplify your question, and then continue doing factoring. I hope that helps. Thank you.